Hey everybody, this is Nate Peterson. This week for my presentation I'll be trying to provide you with some additional information or new information on the two major data exchange formats on the web, JSON and XML. We're going to talk about each one of them and why one may be better than the other or why not, and just talk about their differences and where you might use them and how they look and everything else involved with them as much as possible. And so with JSON versus XML, just start off by describing what they are. XML and JSON are the two most common formats for data interchange on the web today. XML was created by the W3C in 1996, and JSON was publicly specified in 2002. So although their purposes are not identical, they are frequently used to accomplish the same task, which is data interchange. Both have well-documented open standards on the web and are both human and machine readable, and neither one is absolutely superior to the other, as each is better suited for different use cases. So with that introduction, let's just move right into XML. XML is an acronym, stands for Extensible Markup Language. Just like HTML is a markup language, so is XML. But XML, although it's very similar to HTML, it was designed to do very different things. It was designed to do transportation or carrying of data, and not to display it, like HTML is designed for display of data. And like HTML, XML does have tags, but they are not predefined. So you must define your own tags. And XML is designed to be self-descriptive. And we'll go over that a little bit here in a second. But with this, we have an XML example that I'd like to type out here and just show you how to do that, just like you would with an HTML document. So with this, like an HTML document, you have to have at the top a doc type. Well, XML is similar in that you have to declare it as an XML type document. And so to do that, we have a XML declaration at the top, and we have to declare which version of XML we're using. So we'll call this 1.0. But in our example here, we want to describe the data for a user. So we'll have a parent tag of user, and we'll close that user off here and go inside of it. And so what do we need to know about the user? So users have a first name. So we'll give this user a first name. Close that tag off there, and we'll call this user Joe. So Joe is the first name of the user, and Joe needs a last name. And so we can define a tag here for the last name. And Joe's last name, we'll call him test case. Okay, and so what else does Joe need? Joe needs a phone number. So we'll give him a phone number and create a tag for a phone number. And we'll have Joe's phone number be something random. Okay, and so what else do we need? Joe needs an address. So we're going to define an address. But address will have its own set of data here as child tags, and we'll have house number. And so house number we'll say is something like this. And we'll need the street. And the street will say West Wall Street. And city. Town. And we'll say zip code. Goes along with the address well. Zip code. Okay, so this is what XML does really well. Describes data. You can come up with your own tags and describe a user. And this can be done for any type of data that you could envision using. And so there's our example. And XML, just like HTML, has to validate properly. They have to have a root element, and they must have a closing tag. And XML tags are case sensitive, and they must be properly nested within each other. And they must be indented properly, just like HTML, so they can be human readable and understandable when you're working with it. And when you use attributes, with XML tags, they must always be quoted. Sometimes you can get away with not quoting your HTML tags attributes, but that would prevent your code from validating. And XML is it has to have a document associated with it, a document type declaration. For when you're using data exchange with different applications or servers, you have to make sure that the XML is acceptable by one system to another, so that they can interchange data properly. And that's done with the document type definition in XML schema, which is somewhat out of the scope of this. But XML also can be transformed, so you can use it for a lot of different things. You can actually transform XML into HTML so it can display just like a web page would, as long as you provide to that XML file an XSLT style sheet. And there's a great tutorial on how to use XSLT style sheets with XML data to actually make HTML files, or have XML files actually display as HTML in a browser. Well, that's a little bit beyond what we're trying to do here. So the advantages of XML is that they provide a basic syntax and that can be used to share information between different kinds of computers, applications, and organizations. XML provides a method of communication between applications, even if they are on wildly different systems, as long as they can share the data. And XML supports Unicode, which will allow it to display or describe almost any written human language that can be communicated. XML is self-documenting. Its format describes structures, field names, and specific values. And XML allows metadata in its tags in the form of attributes. So let me just go over that really quick here, how XML is self-documenting. So we can go back to our XML example here, and we have the address. And so in the address, we can say something like type equals current, or we could say type equals mailing. And that's how very descriptive XML can be, that we can provide that type of information. So you could have multiple address tags here, one for mailing and one for current, or one for one for summer home, or whatever you want to call it. You can do that with XML, and it's really handy that way. And XML is based on international standards. Some disadvantages of XML is it can be difficult to understand the capabilities that it has, and XML syntax is quite verbose compared to other data formats. And the complexity of XML syntax can negatively affect application efficiency due to transmission and processing overhead. Sometimes it's very processor intensive to parse through XML and use its data. Now, moving on to JSON. JSON is another data exchange format, although it's hasn't been around as long as XML. It's quickly becoming the format of choice to interchange data on the web. JSON stands for JavaScript Object Notation. It's a lightweight data interchange format, and JSON code is valid JavaScript. And so it is completely language independent, and it looks like typical data structures from most other programming languages. So if you're familiar with JavaScript, it's easy to understand. And JSON is built on two structures: a collection of name-value pairs or an ordered list of values. And with the JSON file, you have a file extension of .json. And so that makes it really handy to have its own file format, just like XML. And so we'll go to our editor again and see if we can make a quick example of a JSON file. So with JSON, you'd start it out just like an object in JavaScript. And going back to our user, we'll say first name. And we separate that with a colon, and the first name is Joe. And to separate these name value pairs, we use a comma, just like any other object in JavaScript. Last name, test case, and phone number. Now, phone can be represented as numeric, or in this case, we'll just use it as a string just to make it easy. And so that's our phone number, and we have an address. And using this format that we use for XML, we're going to create a new data structure for the address. And we'll say house number, separate that with a colon, and we'll say 1344 or 1233, house number, and then street, and West Wall Street, city, town, and zip code. And that is what a JSON representation of the same user that we set up in XML. And so JSON, as I mentioned, is a subset of JavaScript, so it's very easy to understand if you're familiar with JavaScript, and it looks like standard programming languages. You can see I have an example here of a complex data structure. Members can be retrieved using dot or subscript operators, and to convert a JSON text into object, you can use the eval function. In browsers that provide native JSON support, JSON parsers are also much faster, and it's really nice that you can actually do that natively in a browser. JSON request is a new way to exchange data between servers just via the browser, where you don't have to use anything special like server-side code or anything like that. And it's something that will probably be used much more in the future. JSON request will work only with JSON text, so it's more secure and can be a very great thing for transmitting data between applications and servers. We'll move over this, and to conclude, given trends indicate that JSON will continue to dominate the web and that XML will continue to decrease. This should not be overblown, however, because XML is still very heavily used in the web and is the only option for apps that use SOAP. Given the widespread migration from SOAP to REST, the rise of NoSQL databases and full-stack JavaScript, and far superior performance of JSON, I believe that JSON will soon be much more widely used than XML in the web, and there seem to be very few applications where XML is the better choice. So with this, I'd like to conclude my presentation. I've gone a little bit over time, but wanted to show you exactly what it was capable of, and I guess we'll be learning more about JSON here this week in our lesson. And if you have any questions about it, leave a comment under my presentation, and thanks very much for listening.